Alright guys, welcome to LT.4.3e, writing biconditional statement as conditional and converse. Alright, so let's talk about what a biconditional statement is. I'll talk about that real quick for your notes. So recall that a conditional statement is a one-way street. So we have P implies Q, where this is my hypothesis and this is my conclusion. Now, this is a one-way street, right? So if P happens, then Q has to happen. So this is one-way street. So if we knew that Q happened, that doesn't necessarily mean that Q happens, right? So I'm going to put this in red. That doesn't necessarily mean, we can't go backwards, all right? However, in a biconditional, bi meaning two, so you have two conditions, you can have a two-way street. You can establish a two-way street. Here, there. Okay, so you have a two-way street. So it goes in both directions. Sometimes we write it like that, and sometimes we just write it like, we just do this, a two-way street. Okay, this is the best way to do it. Let me write that and draw that a little better. Okay, so there's my two-way street now. This is, remember that this is read as P, or if P then Q, right? If P then Q, or P implies Q. Now here, this is read as P if and only if. If and only if Q. Okay, so that's how you read that. P if and only if Q. All right, and so this means that you can write this as two statements. You can write it as the original conditional statement, and you can write it as the converse. So you can write it as the conditional and its converse, which is when you flip the arrow the other way. Now, both of these must be true for the biconditional to be true. So both 1 and 2 must be true for the biconditional to be true. Okay, so that's basically a quick thing on biconditionals. If you can make it so that one of these is false, then you cannot write the conditional. However, if both of these are true, then you can write the conditional. All right, so let's talk about that. Let's look at a couple examples. The table below gives a number of calories for each type of candy in a certain box. Okay. Write the following biconditional statement as a conditional statement and its converse. Okay, so they're saying you have a biconditional. A candy has 350 calories if and only if, so that's the biconditional, the candy is chocolate. All right, so this is statement P and this is statement Q. So right now you want to write it as P implies Q and Q implies P. So P implies Q is if a candy has 350 calories, then it's chocolate. So if a candy has 350 calories, then the candy is chocolate. So that's the original conditional. Okay. Now let's do the converse. So the converse is reversing it. So now if the candy is chocolate, or if a candy is chocolate, then the candy has 350 calories. All right, so there's your conditional and the reverse, the converse. Now use the table to determine the truth value. So the conditional statement, let's look at the conditional statement. Is that true or false? So this is the conditional. If a candy has 350 calories, then it is chocolate. All right, let's look at that. So if it's 350 calories, then chocolate. Okay. Well, all right, so if it has 350 calories, then it's chocolate. That's what they're saying, okay? So let's do that. Okay, so 350 calories, chocolate. right? So far that looks true, right? If it's 350 calories, then it's chocolate. But we have another one that's 350. So what if we ended up pulling caramel? Well, then it ends up making this false, right? So it doesn't have to be chocolate, it could be caramel. So this statement, the conditional statement, is false. Now let's look at the converse. If the candy is chocolate, then it has 350 calories. Is that statement true? Okay, let's look at it. So if it's chocolate, then it's 350 calories. Okay, so now we got, if it's chocolate, then 350 calories. Yes, that's true, right? Clearly that's true from that. So can we write a biconditional? The answer is no. The truth value for the biconditional is false. As long as one of these is false, then the biconditional is false. All right, so now let's look at another example of this. So the table below gives the color and cost of light bulbs that were sold at a certain store. All right, you got the cost in dollars and then the color. Write the following biconditional. All right, so as a conditional and its converse. All right, so the conditional. If a light bulb was red, then it costs $5, right? So that's what we got to do. If red, then $5. Then we reverse it, okay? So if $5, then red. That's the conditional, the converse. Now let's see if it's true. Let's look at the conditional. If it's red, then it costs $5. If it's red, then $5. Check, right? That's it. All right, so if it's red, then $5. So that's true. Now, the converse. If $5, then red. Okay, let's see if that's true. If $5, then red. This is true. And notice that there are no other $5 here. So that means that it can't be a different color. It can only be red if it was $5, right? So therefore, that's true. So is the biconditional true? The answer is yes. In that case, it's true. All right, that's going to do it for the video, guys.